Hello, geometry students. I'm Mrs. Applegard, and today we're going to look at Chapter 9, Section 3, Rotations. The first thing we're going to look at is rotation about a point. A rotation of x degrees about a point Q is called the center of rotation. So Q is the center of rotation. Is a transformation with these two properties. The image of Q is itself. So if you're not moving Q, it's staying where it is. For any point V, right here, Q to V is equal to Q prime to V prime. So the distance is preserved. And the angle between V and V prime, this little guy here, is equal to X. The number of degrees of a figure the number of degrees a figure rotates is the angle of rotation. A rotation about a point is a rigid motion. You write the x degree rotation of triangle UVW about point Q as, and you guys get this, this is the terminology part, this is the language interpretation. Little r means rotation. The first number is the amount of degrees you go. And the second item is the point you're rotating around. Sorry, I'm trying to make it really nice handwriting. Okay, so, and then what goes in parentheses is what is being rotated. So, and that's going to equal our transformed figure, triangle U prime, V prime, W prime. Unless otherwise stated, please note this, highlight, underline, whatever. Unless otherwise stated, rotations in this textbook are counterclockwise. All right, let's do some rotations together. So the first rotation we're going to do our little r's for rotation of 90 degrees around point X of line AB. So here's, let's find line AB, and it's going to rotate around point X, and we're going to go 90 degrees counterclockwise. So bear with me here. Here we go. So we're going to go 90 degrees, which is like a half turn, and I'm going to line my X back up, because remember, our point does not change. And then we look and see what line, state the segment or triangle that represents the image. So AB rotating 90 degrees becomes CD. Okay, we're going to do that same thing. We're going to rotate with RX. We're going to rotate 180 degrees around point X of the line RX. So let's find RX. He is right here. We're going to rotate about point X. There we go. And we're going to rotate 180 degrees, so it's going to go all. So here is 90. Here is 180. And let's line up our X. I can scooch it back just a little. So the line that we go 180 around, it becomes xt. The next one we're going to look at is a rotation of 90 degrees around point D of the line DE. So let's find line DE. Oh, there it is. It's going to rotate about point D. So D is going to stay the same. He doesn't move. And we're going to rotate 90 degrees. So that's going to go, 90 degrees. And then line it back up with D. Oh, so it stays. So instead of DE, we're going to have DC. Okay, and last but not least, we are going to do a rotation of 180 degrees around point X again of triangle AHG. So let's look at where triangle AHG is. It's here, HG. It's right here, this little corner guy. And we're going to rotate him 180 degrees. So he goes 180. This is 90. This is 180. And let's line up our point. We did it around X. There. So when we go 180, we end up not with AHG, but with EDC. So equals triangle EDC. All right, so we are going to now move into, this is just kind of like knowing, and when you look at, if you look at a circle, this is just bonus information. When you look at a circle, like if I'm going to rotate 90 degrees, let me put a center. So if I'm going to rotate 90 degrees, we're usually pretty good at that. It's from here to here is 90. If I'm going to rotate 180, that is all the way across here to here. So it's all the way around. And then 360 is the whole circle. We're going to look at little pieces of the circle. So if we're rotating 60, that is like right here. If we're rotating 120, that's like right here. So just little pieces of the triangle. If we're rotating 240, is 180. 240 is like right here. It's like 180 plus 60 more. 270 is 3/4 of the way around the circle. And then 360 degrees is when we go all the way around. Okay, so as we're talking about rotations, if you didn't know what it looked like, here is a reference for you. Okay, so there is a little formula, yay, for rotation. So when we rotate about the origin 90 degrees, a specific coordinate, x, y, the resulting image is x and y flipped and whatever y was, we make it negative. Okay. So if we look at G as our pre-image, when we rotate it 90 degrees, to get G prime, we switch the x and the y, so it's now 3, 2, and we change the sign of the first coordinate. The rule for rotating 180 degrees around the origin is that we take the coordinates and we change the sign. So if it was 2, 3 before, it is now -2, -3. So that's a rotation of 180 degrees around the origin. If I'm rotating 270 degrees, so it's like 3/4 of the way around the circle, around the origin, I'm going to take my XY coordinates and I am going to switch them and change the sign of the second number. So if I had 2, 3 here is my original coordinate. To get it 270 degrees all the way around, I'm going to go 3, 2, and I'm going to change the sign of the second number. All right, and lastly but not leastly, if I rotate 360 degrees all the way around the circle of my coordinate XY, I'm going to get the same coordinate because I've just come back to where I started. So let's take a look at example 2. We're going to rotate 270 degrees around the origin, the quadrilateral FGHI. And so I'm going to do it using, let's pull the formula out here. So 270 means we switch the x and the y, and we change the sign of the second coordinate. So I'm going to do that. I'm going to write the coordinates, my new coordinates, all down here since they're already on the original ones are on my graph, so I want the new ones to be written down. Okay, so F prime, I'm going to switch the 3 and the 2. So now we're going to have 2 and 3, and I'm going to change the sign of my second value. It would have been -3, but we're changing the sign, so now it's +3. Okay, so for the G, I'm going to switch the -1 and -3, but instead of -3, I'm going to change it to +3. So the second number changes. Okay, so for H, I got -1, -1. That's easy. This becomes -1, and the second number becomes +1. So I change the sign of that second number. And then for I prime, I'm going to switch 0 and 1. So 1 goes first now. And I'm going to write the 0 down because I can't make 0 negative or positive. He stays the same. Okay, and then let's go ahead and graph this. So F prime is over 2 up 3. And remember, we talked to our lazy student and we asked him not to come to our graphing party because we are going to write the letter and the coordinate on our graph with us, just so that we have accurate information as we're learning. G prime is -1 up 3. -1, 3. H prime is -1 up 1. And I prime is over 1 up 0. Okay, and then let's go ahead and connect those dots. Let's do it with purple so you guys can see it a little bit better. F to G to H to I, and then back. And this rotated 270 degrees around the origin. So that's how you use the rule to find your coordinates, because it's kind of difficult to rotate 270 just by eyeballing. So it's nice to have the coordinate rules. Okay, you guys are going to go and do the practice assignment that goes along with this lesson. That's the end of our lesson. So go ahead and do that practice assignment. Come back here when you are all finished and check your answers. I did have to redo all these ones because the first time I did it, I rotated it clockwise instead of counterclockwise. So yeah, fun times. Let me know, ask me during class if there is some tips or tricks that you guys want to see on how to rotate our lines, or if you have any questions about these answers. All right, have a good one. Thank you for playing along.